Our next speaker is also presenting from the Boise location. I'd like to introduce Dave Murphy. Dave is the Lands and Minerals Branch Chief with the Bureau of Land Management in Idaho State Office there in Boise. I've invited Dave to come in today, and he's going to talk a little bit more. He's going to speak to a little bit more of the policies, process, and current activities with respect to public lands. Dave has over 20 years of experience with the BLM, including nearly 10 years as a manager. Dave previously worked in Nevada, Utah, and Wyoming, and at the headquarters in D.C., where he recently joined Idaho about 6 months ago. Prior to joining the government, Dave served for 8 years as a petroleum geologist for Amoco in Mobile, and he moved to Idaho in May of this year. And I'd also like to add that his wife is a Vandal, so go Vandals. Thank you, Dave.
Thank you, Lavina. Appreciate the opportunity to visit with all of you today about energy development and public lands in Idaho. John covered a lot of the current activity in terms of energy development related to public lands in Idaho. In addition, we have approximately 5 wind anemometers or wind monitoring or site testing sites that we've permitted on public land throughout Idaho. And we currently have one part of geothermal exploration is called temperature gradient holes, where they drill shallow holes down into the ground to test whether or not there's a hot spot there, to give you an indication of whether or not it's prospective for geothermal. And so those are the primary current activities on public land. And what I'd like to do is talk about the potential and then how BLM's processes evaluate and permit and monitor and public land energy development. So I'm going to give you a quick overview of BLM Idaho and energy resources. The primary laws that we deal with related to energy development. Talk a little bit about how we use land use planning guides energy development, leasing, permitting, and monitoring, and then primarily give you examples from the oil and gas arena in terms of best management practices that could also translate to geothermal development here, and then talk about what we're doing in terms of requiring reclamation so that we're meeting the mandate of trying to have a multiple use on the public land without permanent impairment to the public land. So BLM Idaho manages 11.6 million acres of surface lands and 36.5 million acres of subsurface mineral estate, which is primarily the national forest. For geothermal and for oil and gas and phosphate, all of the leasables, we do the permitting and do the actual technical work for the permits, and then all of the surface management activities are done by the Forest Service. So as John talked about earlier, 2 of the primary energy potential sources for Idaho are geothermal and wind, and secondarily oil and gas and solar. We really have no known deposits of coal, which is also a leasable mineral that we lease in other parts of the country, and then biomass, that John talked about, is a very, very minor portion of the portfolio for BLM. And so this map comes, and the orange area is geothermal potential area throughout the western United States. It comes from the BLM and Forest Service Geothermal Programmatic EIS in 2008. And you can see that the bulk of Idaho is potential for geothermal, and that's probably, for anybody who's lived here for a long period of time, knows that there's lots of hot springs. There's probably more hot springs in Idaho than any other state in the lower 48. And but let me mention for just a minute that the, let me see if I can pull my cursor over here. This area here in southeast Idaho is also prospective for oil and gas. This gray, or this tan area here in Wyoming is highly productive for oil and gas, and it's called the overthrust belt, and there's actually 3 main overthrust zones, and it's the center one that produces, and the western one is actually in the northeastern corner of Utah and extends up into Idaho. And we actually have 5 oil and gas leases in that area currently. And we have 26 geothermal leases throughout the state. In our land use planning process, we look at potential in a more detailed way for each planning area or field office. And so this map shows low potential. This is for geothermal, the southern half being low potential. This is an area south of I-84 and south of the Glens Ferry area. And the high potential is only that little area in the northwestern corner. And so that's one of the things we do in terms of our land use planning process, is to, on a more detailed basis, map potential as part of our, we use it then in part of our environmental analysis for land use planning. This is a map of an extraction of a nationwide map, and you can see that most of the potential for Idaho is in the southern part, Snake River Plain, and south. However, the pinks and the purples are the highest areas of geothermal, wind potential, and we really don't compare to a lot of the rest of the United States. The central United States has by far the highest wind potential. And so here again for the Jarbidge Field Office, the yellows and the browns are low to marginal or poor to marginal wind potential. The only area in the southeast corner is good to outstanding, and that happens to be the Browns Bench area where the China Mountain Wind Project is proposed right now. Western United States has a fair amount of solar potential. However, as you can see, the red is the highest potential, and all of the commercial development for solar is within Southern California, Southern Nevada, and Arizona. And as you go farther north, there is just less and less in the way of potential. And so I've only heard of one small solar project that somebody's contemplating here in Idaho, and that's on private land. We've not been approached in BLM for a solar project, commercial solar project. So the 4 primary laws that we deal with in terms of energy development on federal land is the Mineral Leasing Act, which guides oil and gas and coal leasing. The National Environmental Policy Act mandates the environmental analysis of any federal action, which is in a formal approval by the, in this case, the BLM. The Geothermal Steam Act provided for the extraction of heat from water as a leasable mineral in the Geothermal Steam Act. And then the Federal Land Policy and Management Act, which is the main guiding legislation for the BLM. And wind and solar are actually permitted through a right-of-way process, which is laid out in the Federal Land Policy and Management Act of '76. And the 3 main things that we're looking for from the Federal Land Policy and Management Act are it provides for multiple use management of the public lands, not necessarily every use on every acre, but providing for multiple use throughout the BLM Idaho, opportunities for public participation, and then land use plans to guide activities. One way to look at land use plans is that they're kind of an overarching guidance for one planning area, in this case, like we saw before, the Jarbidge field office, but we have one for every field office here in Idaho. The National Environmental Policy Act, particularly for the leasable minerals, we start with the initial guidance through land use plan, and we do a NEPA document for that. Then before oil and gas or geothermal leasing occurs, we do a NEPA document, typically an EA for that. When initial exploration, like I mentioned, typically in geothermal, these temperature gradient holes, which are like mineral exploration holes, they're truck mounted rigs that typically drill these, and they're typically done, and then that's another layer of NEPA that's done for that. And then for full development, particularly if it's a larger plant, then we'll look at, even though we may permit individually an individual well, we will then do another larger document looking at the development of the entire project to ensure that we've adequately addressed cumulative impacts. And so we do a separate document for full field development. But as we talked about before, for land use planning, as being an overarching document, it lays the foundation for land management and takes into account all the various resources that are out on the ground, and including socio and economic values also, and looks through the multiple use mandate of balancing resource use and resource protection, and hopefully at that time trying to resolve resource conflicts as much as possible. And so for geothermal and oil and gas in particular, well, also wind and solar, we'll then define areas that are acceptable for development and areas that are not acceptable for development, or ones that will require additional stipulations or controlled surface use. And so, and also identify environmental mitigation measures. And for leasing of geothermal and oil and gas, we will then take those land use plan decisions and memorialize those as lease stipulations. So it's essentially a modification of the overall contract with that operator, and saying we're modifying it so that you cannot do this, or you have a timing limitation here, and we have that essentially as part of the contract, which is the lease document. And so, but part of going through the land use planning process is to look at the different types of resources we have out here. These are 4 examples, like sage grouse, lex, population density, vegetation type, where existing leasing production is, so that we come up with a resulting set of maps showing where we would allow leasing under normal conditions, ones with controlled surface use, one where we do no leasing. So it becomes kind of a patchwork to integrate what they can and can't do based upon the sensitivity of the resources out there on the ground. And for example, for geothermal development, this is the preferred alternative out of the Jarbidge draft RMP EIS from last year. The green area being open to leasing, tan areas with seasonal restrictions, and then the red areas closed to leasing. And so those are typically those areas that have the highest resource values and concerns, and so we have the full ability to put no leasing on those. And so to hopefully adequately address and try to resolve resource conflicts. And so, and here's one for wind development. So the green areas are ones that are open to development, and where it's white, there is it's not available for wind energy development. So I'm going to talk more about oil and gas in terms of just process, but it's almost identical for geothermal, but I just happen to have more examples of oil and gas as we move forward. The only difference with wind and solar is that we don't do leasing of it. It is people come in and initially apply for a right-of-way for site testing, and then with wind, typically for solar, they don't even do site testing, they do computer modeling for solar radiation. And then if they decide that it is prospective, then they'll come in with a permit for full development. For oil and gas and geothermal, there's a leasing stage, which is the first stage after land use planning. And so, as I mentioned before, we do an environmental analysis, typically in EA, sometimes in EIS. And then we hold competitive lease sales by oral auction bidding. And those that are not sold are offered competitively over the counter for 2 years after they've been through a competitive lease sale. Leases are offered for 10 years. If somebody establishes production, then it's held by production for however long they are producing and paying quantities. And so we've got some leases that have been producing for 80 years for oil and gas in other parts of the country. And lease exclusive activities include the ability to drill and develop oil and gas and geothermal and build and maintain improvements. Drilling permits, once they have the lease in place and want to drill and try to develop their resource, then they come in with a permit application, and it typically contains 2 different halves, which is a drilling plan that is more engineering, and then a surface use plan in terms of how they want to develop the surface. And then we do a NEPA analysis. So as you step down from land use planning to leasing to actual permitting, there is an environmental analysis stage with an opportunity for public involvement. And as we do the NEPA analysis, we also ensure compliance with other laws, including the Clean Air and Water Act, the Migratory Bird Treaty Act, National Historic Preservation Act. That's why we have to do archaeological surveys, the Endangered Species Act, and on a case-by-case looking at other resources and potentially requiring resource surveys for those. One of the things we often require are livestock and wildlife exclosures as a condition of approval of the permit, and so that we can protect livestock and wildlife from potential drippage. Well, you see on the left here an oil tank, and then it sits in looks like a stock water tank, and that's secondary containment in case that primary tank leaked, that it would catch that. And so over the years, we've asked them to put grates on, like you see on the bottom left. But if you don't, and there happens to be some leakage of oil, then you can get a case where you may have birds or other wildlife injured by the oil dripping from the tank. We also do wildlife monitoring both before the permitting and then also after to if we provided for conditions of approval or lease stipulation saying that they need to like not drill in the springtime to protect sage-grouse lacs or a number of different things, that we want to ensure that the things that we're requiring are effective. So we want to monitor to see whether or not there's even herds there anymore compared to when there was initially when we did the land use plan, if it's a number of years old, seeing what the effects of our permitting and or the activities are on wildlife. And so, which brings me into, we're gradually working with operators to have them implement best management practices to protect the landscape in terms of minimizing footprint, reducing contrast, and improving reclamation. So what we've had, the slide shows over here on the left where development has gone on, where everything is a separate road, a separate path, a separate drill pad for each and every well. But if you can consolidate those, you can reduce the footprint and hopefully come up with a situation like you see on the right. For example, directionally drilling from a single well pad. In this example, there's 16 wells that have been drilled all from one drill pad. The first few would be drilled vertically and then gradually directionally drilled out in different directions to develop that oil or geothermal field. And so what we're doing is reducing the overall footprint of that development as a result of concentrating wells on one pad, and therefore you've got one road instead of 16 in there also. And also looking at reducing the visual impacts of development. As you can see in these three slides, that if you use our BLM has a standard environmental colors chart, which is in the bottom right, and working with operators to choose a color that blends with that particular environment. So you wouldn't use a gray that might look well out on the Snake River Plain in an area where you have a lot of juniper. You would then pick a color that is appropriate. And if you do that, you can see that it greatly reduces the visual impact of development. And then we also work with operators to have interim reclamation done. So you may, as you see in the upper right, upper left, that was probably a 5-acre drill pad with a large well, drilling rig and various other pieces of equipment. And what we've had them do is to reduce that drill pad to a much smaller production well pad, which is well less than an acre. And so we've probably reduced that footprint and reclaimed on an interim basis 80 or 90% of the initial surface disturbance. And we can do the same thing with the roads here on the right, where we're having them pull in that initial road to not much more than a true track instead of this rather large gravel road that was needed to haul in these huge flatbed trucks with a lot of equipment on it for drilling. And one of the most important things we do in the BLM in terms of oil and gas or geothermal development is ensure proper plugging of wells so we don't leave an environmental problem to our children. And we work closely, and that's one of our highest inspection priorities, is to ensure that it's plugged and cemented well so that we are ensuring protection of all zones of usable water and other oil, gas, geothermal, and other mineral resources. And so, and then eventually when there's final reclamation done, this happens to be a well that was not successful, so final reclamation occurred right after the initial activity. And so, but the idea is so that we can restore the landscape and wildlife habitat and rangeland so it can be used for things after this activity has been completed. And one of the things we do is, instead of a practice that was often done 30 years or more ago, was to just plant crested wheatgrass to get something to grow out there strictly for erosional purposes, to now require using native seeds and a variety of plants to to better reestablish what the original native vegetation was out there, and then to do monitoring to ensure that that revegetation has been successful. And we require bonding for operations, and we don't allow that permit to be closed until after they've not only fully plugged the well, reclaimed the surface, and had revegetation success. And so here's an example. On the upper left, that's what it looked like when it was initially drilling 3 years after initial reclamation, and then 17 years later where we've had really good revegetation success. And that's our goal, to ensure that energy development is a temporary use and not a permanent scar on the land. And so as a part of our multiple use mandate, we're seeking to help provide that energy that John talked about earlier, while minimizing the footprint of development. And is there any questions? Will? Okay, go for it. Let me answer it this way. The primary goal is to ensure on-site mitigation. Off-site mitigation is well down the road if we cannot have on-site mitigation occur. And so if it's possible, if we feel that there isn't going to be success for whatever reason right at that site, or that disturbance is going to be there for so long, then we may enter into discussions with an operator in terms of providing for off-site mitigation to help offset that permanent or long-term degradation of the particular area. Sometimes that we would approach that more in terms of mining than with oil and gas or geothermal, because in general, it's, as you've seen with these slides, it's easier to do that sort of reclamation on site. Sometimes, say, if there would be a mine, say in a little intermontane basin, say in the mountains, say south of the Snake River Plain, for example, you've got a little wetlands in there. Well, if you're going to put a mine pit there, there is no way you can ultimately replace that, except maybe in geologic time. And so in some case like that, that would be one of those permanent ones I'm talking about. And so we would then approach the operator in terms of providing off-site mitigation to, say, help enhance, say, a degraded wetland maybe somewhere else. Any other questions?
I've got a question for you relative to your relative to measuring success of your revegetation. Can you speak a little bit to how you define that? Is that a certain percentage of the native vegetation, or how do you define success?
Good question. The best way is to try to survey it in some fashion through typical range techniques, whether it's line intercept or what other method, and have a survey of what the native vegetation is before the vegetation is disturbed, and then trying to, we may not be able to provide that exact same set of vegetation because some of them will take so long to reestablish that we will come up with a reclaimed vegetation scenario, and then set up criteria based upon that same range survey method to then say, okay, it may not be the exact same, but this is what we feel will be successful. And so not only in terms of frequency, but diversity of the plant species we're looking for.
I noticed both you and John spent most of your time talking about exploration and production. I think one of the bigger impacts in Idaho right now is transmission corridors. I was wondering if you might get into those issues a little bit.
I'm sorry? Oh, I'm sorry. The question was, what about, in essence, what about transmission? Oh, yeah, I had focused my talk, as you rightly talked about, in terms of the actual energy sources, but we have three primary transmission line projects we're working on, at least in BLM at the moment, and that is Gateway West, MISTY, the Mountain States Transmission Intertie Project, and the Boardman to Hemingway. And both the Boardman to Hemingway is basically near Murphy, and then the vast majority goes on up into Oregon near Pendleton. Gateway West basically comes from Wyoming to western Idaho, and then Mountain States comes from north of Dillon, Montana, and down to, I believe it's midpoint in south central Idaho. And a lot of the analysis is going to be the same in terms of, okay, where is the line going, what resources are going to potentially be impacted. And unlike oil and gas and geothermal, where the resource is where it is, we do look at a number of alternatives. 6, 8, 9, so quite a few, and then to try to minimize impacts to various types of resources. So, any other questions?
John, this is, excuse me, Dave, this is Lavina in Moscow. I had a question with respect also to transmission lines, and it just seems like there is an awfully big push to get a lot of transmission lines up. And I was wondering if you could speak a little bit to some of the West-wide energy corridor plans, and also tell us a little bit about the challenges of integrating the less dependable renewable energy like wind with some of the aging infrastructure of the existing transmission lines.
I think I heard most of your question. One of the key things for renewable energy, because it's electricity generation, is trying to develop it near major transmission lines. And those may or may not equal what was in the West-wide corridor EIS from a few years ago. And in fact, we got sued on that, and that's working its way through court. But the one key thing about the West-wide corridor EIS was that it only identified public lands. And so because we had no control over where lines might go off of public lands. And so, I mean, that was a similar exercise, but on such a huge scale, you cannot do the detailed analysis you do for each and every individual transmission line. And so part of the goal of that was to provide some information for planners going from them and then going out to the future as to where those major transmission lines may be and could be developed for planning purposes for the utilities and public service commissions. Yes, sir. permit renewals? Yeah. They certainly could be. It would all depend upon the total number of acres that they would actually be disturbing. I mean, at this point in Idaho, we don't have any that are of such a magnitude to have a significant impact upon the AUMs. And so, yes, I mean, in some other parts of the country where there would be a much larger impact, then they would be considered because it would be from the standpoint of what the total available forage would be. Any other questions?
Can you hear us here in Jerome? Acknowledgement? Hello?
I can hear you.
Oh, excellent news. All right, this is Stephen Paulson. I have a quick question. We've done a lot of restoration in most of the western states that have a lot of oil and gas development. One of the chronic issues we see on public lands is a very large gap in restoration similarities for release criteria between field offices, even inside of any one state. Has Idaho, given its unique opportunity to get in front of that potential problem, have you guys talked about that in Idaho yet? Are you trying to get consistent between field offices?
We do our best to try to be consistent. Obviously, when you're dealing with individual resources that are a little bit different between field offices and also different personnel that may be trying new things or evaluating things a little bit differently, you may hopefully will only see minor differences rather than major differences. We, having come from the Washington office, we do our best to define consistent policy that will be applied by all the field offices throughout the country. And but here in Idaho, since we don't have very much, a lot of the expertise related to particularly oil and gas and geothermal development actually resides in my office, and we are working with different field offices, and hopefully that will result in greater consistency between those field offices.
Thank you.
Well, if there's nothing else, I'll turn it back over to Brandon.
Dave, thank you very much. Let's give a hand to Dave.